3, 2, 1, 0. Ignition. Liftoff of the Falcon 9 and Crew Dragon.
Transporting things and people to the farthest depths of outer space is one heavy ordeal. It is indeed a tall task because not only it requires the technical know-how in operating rockets, but also you need to consider the right materials and equipment that come along in building those. To the not-so-tech-savvy peeps out there, it is quite indeed a pleasant view seeing this huge bulk of heavy metal thrust towards the sky at an incredible phase. But to those who have burning curiosity, treat this video as a gift because we will unveil some of the secrets and answer some of the questions on how SpaceX builds these massive and metallic flying objects. If you think this ain't rocket science, well, you better think again. By the way, make sure to hit subscribe and tap the notification bell first so you wouldn't miss our videos. Don't forget to give this video a thumbs up and tell us your thoughts about Elon's space-conquering aspirations by leaving your comments below. Now that's settled, let us break down the parts and pieces that made SpaceX's Falcon 9 rocket.
3, 2, 1. Liftoff of the Falcon 9.
For someone who's living and breathing the possibility of planetary colonization, money is not that big of an issue. During a return flight to the United States, tech visionary Elon Musk realized that he can produce affordable and reusable rockets instead of outsourcing rocket-building materials at an overpriced cost. As a result, Space Exploration Technologies, or SpaceX, was born. Within just a few years, the privately owned aerospace manufacturer had conducted multiple launches and resupply missions with a fair share of success and failures. In 2012, SpaceX made history books when it became the first private space company to deliver cargo to the International Space Station. 3 years later, SpaceX made another scientific breakthrough when the Falcon 9 rocket successfully re-entered the atmosphere and landed vertically after separating from the second stage. As of 2020, Falcon 9 has the most launches among all U.S. rockets currently in operation, and the only U.S. rocket fully certified for transporting humans to the International Space Station. Aside from these remarkable milestones, it is also considered the only commercial rocket to launch humans to orbit. Elon Musk has done the almost impossible, and now he is on the brink of bringing people to Mars as he tries to make commercial spaceflight accessible for every walk of life. In its most basic sense, the Falcon 9 is a two-stage rocket. At liftoff, the first stage is responsible for accelerating the vehicle, and at some point, the second stage detaches from the first stage and continues to orbit under its own power. Both stages are powered by SpaceX Merlin engines, which is a family of rocket engines made by SpaceX that was used on Falcon 1, Falcon 9, and Falcon Heavy launch vehicles. These engines use liquid oxygen and RP-1 rocket propellant, in which the latter works similarly to jet fuel. Overall, the Falcon 9 stands almost 70 meters in height, weighs around 550,000 kilograms, can generate 7,607 kilonewtons of thrusting power at takeoff, and it also has a 4,020 kilogram of payload capacity in case it tries to transport cargo to Mars. One of the most amazing technological feats of the Falcon 9 was the attachment of the octaweb in its first stage. In the prior versions of the Falcon 9, they used 9 engines arranged in 3 rows of 3. With the octaweb, they improved the positioning of its structure by placing 8 engines that encircle the central core engine. This change-up enables to reduce the length and weight of the Falcon 9 thrust structure. It also allowed SpaceX to keep their launch costs down because the octaweb helped them to streamline their manufacturing process. In total, the Falcon 9 can generate more than 1.7 million pounds of thrust at sea level. As I've previously mentioned, Falcon 9 harnesses the power of the Merlin engine as the main source of its thrusting power. SpaceX has been building Merlin engines in-house since its earliest versions. Its turbopump spins at 36,000 revolutions per minute that is capable of delivering 10,000 horsepower, or equivalent to 7,500 kilowatts. In terms of its overall performance, it has a thrust vacuum of 981 kilonewton, which is roughly equivalent to 221,000 pound force, and boasts 845 kilonewton at sea level, which exactly amounts to 190,000 pound force. The most crucial juncture of a two-stage rocket is its separating phase, and this is where Falcon 9's inner stage comes to play. The inner stage is a composite structure that bridges the first and second stages. This integral part is responsible for separating the two stages from one another using pneumatic pushers, which is a simpler method compared to other intricate pyrotechnic systems. Compared to the multi-engine thrusters of its first stage, the second stage of Falcon 9 is powered by a single Merlin vacuum engine as it continues to traverse towards the Earth's orbit. Falcon 9 payload fairing is made out of a carbon composite material and serves as a protective barrier to shield the spacecraft's payload from dynamic pressure and aerodynamic heating. Meanwhile, its main payload, called Dragon, is capable of housing up to 7 people that stands 26.6 feet and measures 12 feet in diameter. To ensure that Falcon 9 avoids disaster as it free falls after the separation, 4 hypersonic grid fins were also installed in order to control the rocket's descent. Grid fins or lattice fins are aerodynamic devices that look like waffle irons or tennis rackets, except that each one has the size of your normal kitchen table. The fins pop from the booster's sides and act like a parachute that steers and guides the rocket back safely towards the landing pad during the vertical landing phase. Lastly, the first stage is equipped with 4 landing legs which are located at its base to stabilize the rocket upon its landing. These supporting structures are made out of top-quality carbon fiber with aluminum honeycomb, and each leg has a shock-absorbing system to absorb and withstand the force of impact. With the unprecedented success of Falcon 9, the chances of migrating to another planet have literally and figuratively skyrocketed into a new level thanks to SpaceX CEO's unwavering stance that cheaper rockets can bring humanity one step closer outside of Earth. Do you think we can finally walk around the edges of Mars by 2026? And what do you think we should do first when we get there? I want to know your thoughts on this one by dropping your answers down below.